Welcome back. The objectives of this video are to explore partial fraction decomposition. We'll look at two sample problems, one using distinct linear factors and a second using repeated linear factors. If you want, you can go out to Moodle and click on this link. There's another video option available from your textbook, or you probably can access it through WebAssign or the online textbook. So let's take a look at the use of partial fraction decomposition. And the first one here using distinct linear factors. So you'll be asked to write the partial fraction decomposition of some particular fraction. Well, the first thing we want to do is factor the denominator. So we can factor x squared minus x minus 6 into x minus 3 and x plus 2. And each of these factors will become one of the denominators of our partial fractions. So it says here you should include one partial fraction with a constant numerator for each linear factor of the denominator. So once you factor your denominator, rewrite your original question, in our case x plus 7 all over x squared minus x minus 6 equals, and then a over one of the factors, in this case x minus 3, and b plus b over x plus 2. So our process in order to solve for a and b, so that's what we're going to need to do. We need to solve for a and b. So the first thing we're going to do in our process, one, we're going to multiply both sides by the common denominator. So multiply by x minus 3 times x plus 2 on the left, multiply by x minus 3 times x plus 2 on the right. So that's going to get our denominator to cancel and leaves us with x plus 7 equals a times x plus 2 plus b times x minus 3. Go ahead and distribute the a and b. So we get ax plus 2a plus bx minus 3b. We'll do a little rearranging here. So our x's are together. So we have ax plus bx plus 2a minus 3b. And that, of course, is all equal to x plus 7. Well, we have got a common factor here in ax, bx. That's why we arrange those. So we'll factor out that common factor, and we get x times a plus b plus 2a minus 3b. Now keep in mind that the left side here is equivalent to the right side. We have x times a plus b, but we also have 1x here. If I have 1x and x times all this and the right side is equivalent to the left side, that must mean the 1 is equal to a plus b. It also means that 7 is the equivalent of 2a minus 3b. So interestingly enough here, we're going to be able to put together a system of equations. I'm going to go back a little bit and make some quick notes about what our process was. So we multiplied both sides by the common denominator, we simplified, and we rearranged our x's together here so we could factor out the x. Then, since both sides were equivalent, we essentially created a system of equations. So my system of equations, the first equation is a plus b equals 1, right? My coefficient on x, a plus b, is my coefficient on x on the right, so my coefficient on the x on the left is 1. And then 7 has to equal 2a minus 3b. And now we go ahead and solve the system. So I'm going to solve the system. It looks like I'm going to multiply, looking at my notes, I'm going to multiply the top equation by 3. So I get 3a plus 3b equals 3, and now I can add those two equations. 5a equals 10, so I see a is equal to 2, b is equal to -1. So now I know what my a's and b's are, so looking back at my original equation, my original question, x plus 7 over x squared minus x minus 6 is equal to a over x minus 3, or in this case, 2 over x minus 3, plus b, or minus b, minus 1 over x plus 2. So there is my final answer. Now we'll do a second example using repeated linear factors. So you'll be asked to write the partial fractional decomposition of this fraction. And just like we did, we are going to go ahead and factor the denominator. So that's going to be our first step, is to factor the denominator. So our denominator has factors of x and x squared plus 2x plus 1. Well, that is still factorable. That is a perfect square trinomial. So that factors to x times x plus 1 quantity squared. So we have two factors of x plus 1. So now, since we have three factors, we're going to work with both all a, b, and c. So we'll write one partial fraction with a constant numerator for each power of x and x plus 1. So our original question here on the left, a over one of our factors x, b over one of our factors x plus 1, and c over x plus 1 quantity squared. And we'll follow the same process we did before. We'll begin by multiplying by the common denominator to get the denominator to cancel. So I'm going to multiply everything by x times x plus 1 squared. In doing so, on the right side, or I beg your pardon, on the left side, my denominator cancels. So I get 5x squared plus 20x plus 6. And on my right-hand side, the x cancels, so I'm left with a times x plus 1 quantity squared plus b times x plus 1 plus c times x. So as I did in the previous sample, I'm going to have to multiply this out and simplify. So x plus 1 quantity squared, I have to do that first. That is our perfect square trinomial, so I get a times x squared plus 2x plus 1 plus bx squared plus bx and plus cx. Now I still have to distribute the a over here, so I get ax squared plus 2ax plus a plus bx squared plus bx plus cx. So I'll just copy that down. And all that is still equal to 5x squared plus 20x plus 6. Okay? So my second step here, I've simplified. And now my third step, I'm going to rearrange. I'm going to do some rearranging. So I'm going to rearrange. I'm going to group my x squareds and my x's, and then my constants, or anything that's left over. So my x squareds, it looks like I just have ax squared and bx squared. And my x's, I've got plus 2ax plus bx plus cx. And then I have a plus a. So kind of make this a little bit easier, I will use some parentheses here to show my three groups. So I've rearranged. So I've got my x squareds and my x's and my constant. My next step is I will factor out the common factor. So when I factor out the common factor, I factor out x squared, and I'm left with x squared times a plus b. And here I factor out in the middle, I factor out an x, and x times 2a plus b plus c, and then I have plus a. So now, since our left side is equivalent to the right side, 5x squared, well, a plus b must correspond to 5. 2a plus b plus c must correspond to 20. Because that is essentially the coefficient. 2a plus b plus c is the coefficient on x, as is 20. And then a must equal 6. Rewriting this, and I'm going to be intentional about how I rewrite this. I'm going to create a system. And if we think about our Gaussian elimination method, we want to start, I'm going to start with 2a plus b plus c equals 20. So 2a plus b plus c equals 20. And then a plus b equals 5. And finally, a equals 6. So this is a little bit backwards from what we've seen before, but I can do back substitution here simply to solve my system. While I was writing that, you probably solved the system already. So we know if a equals 6 and a plus b equals 5, so 6 plus b equals 5, so b must equal -1, and substituting in to our top equation, a is 6, 2 times 6, minus 1, plus c equals 20. So 12 minus 1 is 11, so if I subtract 11 from both sides, I get c is equal to 9. So now I have my values of a, b, and c, and I can write my final answer. So my final answer, 5x squared plus 20x plus 6, that'd be x cubed plus 2x squared plus x, equals a, or 6 over x, minus 1, or b over x plus 1, plus c, 9 over x plus 1, quantity squared. And that is our final answer. So there's your introduction to partial fraction decomposition, and you'll get a couple more problems to work like this when I see you in class.